So example 2 gives a cosine value. So again, we should think x, and cosine's negative, so we should be thinking negative x, so it should be located in quadrant 2 and 3. Now, the question does give us the quadrant, so that's very important. So although we have to consider two angles, we're only going to give one angle as the solution. So drawing in the cosine value, so negative 8 and 11, so I'm going to draw it maybe like this. Okay, so that's going to be a radius of 11, and the x positioning is at negative 8. Okay, so there's my position, and the angle that I'm looking for is this one here. This is my theta angle that I'm looking for, and when I solve this, I'm going to use the arc cos. I'm going to undo the ratio of negative 8 over 11, and that's going to give me my theta 1 angle. Actually, I'm going to just do this in a different color. Okay, so if I do the arc cos of negative 8 over 11, that gives me my theta 1. So I'm going to call the one for my calculator theta 1, and my calculator gives me a value of 136.66 degrees when I round that. Okay, now it's important to recognize which quadrant 136.66 degrees is in. So here's 180 degrees, here's 90 degrees. 136.66 is in quadrant 2. And in fact, it is going to be the symmetrical angle, symmetrical position in quadrant 2. So this still has a negative x coordinate of negative 8, but this one goes up instead of down, which we can't tell just from the cosine ratio, but we can tell from the quadrant. Okay, so we want quadrant 3. The angle that we're looking for is not the blue angle, but the quadrant 3 angle is that red angle that we have down here. Okay, so that's locating that position. So that's going to be theta 2. So although our calculator gives us the theta 1 angle, it doesn't match the quadrant that we're given. So this 136.66 degrees has to be converted into theta 2 angle. And so I'm just going to go find theta 2. And there's, again, lots of ways we can do this. I could use a reference angle. Some people like to use that. But I'm just going to use a symmetry. Instead of going 136.66 from 0 to the right to in the positive, I'm just going to go in the negative. Okay, so that position angle is negative 136.66 degrees. So theta 2 is going to be 136.66 degrees in the negative direction. That's important. That's gone in the negative direction. That's theta 2. That negative angle will locate that red dot. Now, the previous problem said between 0 and 360. This one doesn't. So this is good enough. If I want to convert this into an angle, positive angle, I will just use my 360 degrees and subtract 136.66. Or I can just go add 360 to the negative 136.66. In either case, we get the same answer, and that's going to be the quadrant 3 position of 223.34 degrees measured in the positive direction. So this theta 2 we measured in the positive direction is 223.34 degrees. And again, these two angles here are the exact same angle. They're the exact same position, although they're just coterminal, meaning that they find the same location going different directions.